we are skipping the do now. So we just finished surface area, and now we're going to talk about volume. Before the NJSLA, oh, say the pledge first. Okay, so before the NJSLA, I gave you a little brief overview of volume, so now we're going to really get into it. Definition, the volume of a solid I can't hear anything from this guy. Is he done? Okay, so he's done. Okay, so definition, the volume of a solid is the number of cubic units of space contained by the solid. So remember, I had told you surface area is, we're painting, everything we're painting is sort of considered like a separate entity. Like, okay, well, what can I paint from this? What can I paint from that? For volume, it's seeing how much something can hold. So now instead of units squared, because for surface area, we're saying how many, 1 by 1 squares, two-dimensional, can fill a space. For volume, it's how many cubes. Now we're 3 dimensions. How many cubes can fit a space? So that's why at the end we say units cubed or cubic units, because now we're saying how many 3-dimensional cubes can fit in there. We don't care about that. Let's just go right into formulas. All right, the volume of a right rectangular prism is equal to the product of its length, its width, and its height. And you guys know that. Length times width times height is the volume of a rectangular solid. Okay, because a rectangular solid is considered a prism, it will follow the formula for all other prisms, which is area of the base, remember that capital letter B we had discussed, times the height, where B is the area of the base. And that formula, that big capital letter B times the H, works for any prism under the sun. Okay, just to recap, remember, we name prisms by their bases. So this first one is a triangular prism because the bases are triangles. I don't know how many sides this is. 1, 2, 3, 4, 5. Okay, so this is 5 sides. So this is a pentagonal prism. Right, this is not this is not a shape. Right? If we had to find the volume of that, what you would do is you would split it into 2 rectangles. Find the area of each rectangle and then multiply it by the height. All right, so the volume of any prism under the sun is that capital letter B times H, where that capital letter B is area of the base. All right, volume of a cylinder is the same thing. Sorry, furthermore, since the base of a cylinder is a circle, there we go. There's a second, more popular formula. All right, I'm going to categorize cylinders and prisms in the same format. We're going to do area of the base times the height, where that big capital letter B is area of the base times the height. And we know, isn't the base a circle? So this is pi r squared times the height. We do not need to know about cross sections, so we can cross this all off. All right, let's just get into our sample problems now. So we want to find the volume of the rectangular prism. So we have choices. We can do, because it's a prism, area of the base times the height, or more specifically, for a rectangular prism, isn't it length times width times height? So it's, I think this is the easier one. So it's going to be 20 times 5 times 15. 20 times 5 is 100, times 15 is 1,500 units cubed. Okay, number 2, find the volume of the triangular prism. Okay, because it's a prism, what formula do we use? Area of the base times the height. That big capital letter B is area of the base times the height of the whole prism. Okay, so do we all agree the base is a triangle? So I'm going to redraw that triangle to find its area. This is 10, 10, and the base is 12. And the area of a triangle is represented by half the base times the height. Well, we know the base of this triangle is 12. Do I have a height? No. Since I don't have a height, what am I going to have to do? Excellent. We're going to need to draw an altitude. And when I draw that altitude, that 12 gets split into 2 6s. This ends up being a triple times 2. It's not a 3, 4, 5. It's going to be a 6, 8, 10. So I'm going to say half of 12 is 6. 6 times 8 is 48. So now, y times 2. Oh, it's not surface area. We're not painting. So it's just the area of one base times the height of the whole prism. So the area of this base is 48. Now, something you need to know that will make or break the problem. When you decide the height, the way it's standing right now, wouldn't you consider the height of this triangular prism is the altitude here of the triangle? Right, that's not the height. When you decide the height of a prism, it needs to be standing on the base. What's the base? No, shape, triangle. The base is a triangle. So I'm going to rotate this triangular prism so it's standing on the triangle. If I'm rotating this so it's standing on the triangle, what is the height of the prism? 15. So anytime you choose a height, you want it or you need it to be standing on its base. And then that height is the height of the prism. Can somebody do 48 times 15 for us? Say it one more time. 720, thank you. 720 units cubed. Can I move on to number 3? Okay. Volume of a cylinder. Volume of a cylinder. Well, isn't the volume of the cylinder the formula the same as a prism? That big capital letter B times H. So that's going to be area of the base times the height of the whole prism. Well, do we agree the base is a circle? So we're going to say pi r squared times the height of the whole cylinder. What's the radius here? 3. So we're pi 3 squared. What's the height? 12. So now we are 9 pi times 12, which is going to give us 108 pi units cubed. You got it. Volume is actually a lot easier than surface area. Surface area is very tedious. There's so many parts to it. Volume, as long as you get an understanding of how the formula works, you could pretty much do it pretty easily, I should say. All right, so number 4, there's 2 different ways to do number 4. You could look at this and say, okay, well, I have one rectangular prism on top of another rectangular prism. I could find the volume of the bottom one, find the volume of the top one, and then do what? Add them together. Or the way I'm going to do this, that's even easier, is I'm going to say, okay, well, this whole thing is still a still a prism, not a rectangular prism. The whole thing is a prism. What are the bases? Those like boxy T's, right? I'm going to highlight the base in yellow. Well, isn't the volume of any prism area of the base times the height? Is there a formula for area of a boxy T? No. So what I'm going to do is split this boxy T into 2 rectangles. All right, do we agree that the base of the bottom rectangle is 7? What's the height of the bottom rectangle? 4. So the bottom rectangle has an area of 28, right? Now let's go to the top rectangle. Aren't opposite sides congruent? So if this is 2, this is also 2. And then since the opposite sides are congruent, if this is 5, this is also 5. So that top rectangle has an area of 10. So what is the area of the base? Not 10, not 28, but 38. You got it. Now when we choose the height of the whole prism, good. What'd you say, Sarah? Excellent. We're going to stand it on its T. When I stand it on that boxy T, how tall is it going to be? 10. You got it, Henry. So what's the volume here? 380 units cubed. Is it not 380? No? It is. Henry, making me doubt myself. We're crossing out number 8. We do not need to know about any of those plotting coordinates. All right, so now we have a few more, and then we will be done. I'm also going to take off some of your homework. Trying to keep it simple for you guys. Trying to keep it simple. Okay, so if this was surface area, oh, what a pain it would be, right? If this was surface area. Like, okay, we're painting the rectangles. We're painting the top hexagon. We're painting the bottom hexagon, right? There would be so much involved, right? But we're not painting. We're not finding surface area. We're finding volume. So oh, yeah, I don't want to find the surface area. Sorry. Find the volume. All I care about is volume. We're done with surface area. In the past, I used to make one whole test of surface area and volume, but this time I'm just doing volume. Okay, so what is the volume of the regular hexagonal prism? Because it's a prism, what is the formula? Area of the base times the height. Area of the base times the height. Ugh, I'm the worst at drawing. They should, if you want to be a math teacher, they should make you take like a geometric drawing course. All right, so because this is a regular hexagonal prism, and the bottom side of the rectangle 6, the top side is 6, that means every side of this hexagon is 6. Now, who remembers how to find the area of a regular figure? Excellent, half AP. Well, we already know the perimeter. The perimeter is 6 times 6, which is 36. But now we have to find the apothem. Who remembers how we go about finding the apothem? Henry. Yes, we draw radii to the corners. And then those top angles become how many degrees? 60, because we took them and split it into 6. And now I'm going to draw the apothem. What is the apothem? The altitude of this triangle. When I draw that altitude, that 60 is going to get split into 2 30s. And that 6 on the bottom is going to get split into 2 3s. So you need to remember that opposite the 30 is x, opposite the 60 is x root 3, and opposite the 90 is 2x. So what is the apothem? 3 root 3. You got it. So I'm going to take half of 36 is 18. 18 times 3 root 3 is 54 root 3. What does this represent? 54 root 3. Area of the base. So we're going to go back into our formula. The area of our base is 54 root 3. What is the height of the whole prism? 10. So we're going to be 540 root 3 units cubed. We ready? Anybody still copying? Okay. So number 7, find the length of a lateral edge of a right prism with a volume of 286 and a base area of 13. Okay, so first thing I recognize is they say in the same problem, volume and prism. So what do we know? The volume of any prism is area of the base times the height. Now, the height, go back to our prisms. You guys don't have to do this. All right. In our prisms, isn't the height the lateral edge? Yeah, the height is the lateral edge. So when they say find the lateral edge, can I find the height? Yeah. So find the length of a lateral edge, we could also call it the height, with a volume of 286. Where am I going to substitute that 286 in for? B, because it's saying the volume is 286. And then it says the base area, that's the same as area of the base, is 13. So where's that 13 going in for? B. And now we're solving for the height. How do I solve for the height? Divide by 13. It does go in evenly, I think. How many times? 22. Thank you. So the lateral edge is 22 units long. We ready for the last problem? Don't worry about the cross section. That's the top. So, what do you think happened, or what do you think this was initially? A circle? A cylinder, three-dimensional. All right, a cylinder, okay? This was initially a cylinder, and then what happened to it? Chipmunk came and took a big bite out of it, okay? I don't know if a chipmunk really came and took a bite out of it, but it looks like it. You see, like, it looks like the teeth went in. Okay, but because it was a cylinder, what is the volume of a cylinder? Big B times H, area of the base times the height. This is so much easier than surface area. This is so much easier than surface area because I'm not painting. So it says area of the base. Well, I gave you a little idea of what the top looked like. Isn't this now the base?
Yes.
All right, so what has happened here? If I'm trying to find the area of this thing, didn't it seem like a semicircle with two little semicircles cut out of it? So area of the base is going to be area of the semicircle minus 2 times the area of the small semicircle. Does that make sense? Yeah. Times the height. All right, area of a semicircle, isn't it pi r squared over 2? Half a circle? Well, I told you the diameter here is 12. If the diameter is 12, what's the radius? 6 and 6. So it's pi 6 squared over 2, which is 36 pi over 2, gives us 18 pi. Okay, now we need to find the area of the semicircle. Well, the diameter of this semicircle is 6, so what does that mean for the radius? 3. You got it. So now, question for you, to make things easier. If you don't want me to do this, I don't have to. What if these two semicircles make one full circle?
Yes.
So do you guys want me to find the area of each semicircle and add it together, or multiply by 2, or just do one full circle? What would you all do? You don't know?
I feel like I probably would have just times it by 2.
Times it by 2, good. All right, so let's find the area of the semicircle. So isn't the area of the semicircle pi 3 squared over 2? So that's going to be 2 times 9 pi over 2. But what happens with the 2's? They cancel out. So this is going to be 9 pi. 18 pi minus 9 pi is 9 pi. And now we're going to times this whole thing by the height. What's the height of the whole bitten chipmunk cylinder? 10. So 9 pi times 10 is 90 pi units cubed. All right, let me see. That's the end of today's lesson. Let me see what homework I want to take off.